All right, so let's take a look at the first one today. This one says a function f of n equals 85n is used to model how the distance in miles traveled by a train traveling 85 miles per hour in n hours. Who it was. Okay, so that makes sense, right?
What did it say?
It said yay or something like why. That makes sense, right? Because the train's going 85 miles an hour. So if you plug in 1 for n, 1 hour, it's gone 85 miles an hour and so forth, right? Okay. Identify the independent and dependent variable in this function. So you've got two variables, distance. Do you guys see that okay?
Yeah. No. I can see it perfectly. I do realize. I'm not geographical.
Okay, you've got two variables. Distance and time. So the question is, does the time the train travels depend on how far it has gone, or does how far the train travel depend on how long it's been traveling? How long it's been traveling. So the dependent variable is distance. Because the distance depends on the time.
Do we have to write that whole sentence down?
I already answered that question. Okay? So for number one today, the independent variable is time, and the dependent variable is distance. Okay? Any questions about that? Okay. All right, next one, which will be number 2 for us, says what is the domain of the square root of x minus 2? This is something that we talked about, I believe, on Friday. What numbers can you not take the square root of? Negative numbers. So if I'm going to try and take the square root of x minus 2, what's the smallest number for x that I can plug in and get an answer? No, because if I plug in 0, 0 minus 2 is negative 2. I can't take the square root of that. What? 2, because 2 minus 2 is 0, and I can take the square root of that. Can I take the square root of numbers bigger than that or smaller? Bigger. So I need x to be greater than or equal to 2. So my domain is x is greater than or equal to 2, because if I put in a number bigger than or equal to 2, I'll get an answer. If I put in a number less than 2, I get a negative number. Can't take the square root of that. Doesn't make sense. Okay? Any questions on that? All right, so let's see what you have learned. What is the domain of f of x equals the square root of x plus 6? What's the smallest number I can put in for x in that? What?
No, he just says whatever number it is. Oh, okay.
This is our third question we're doing today, so it is number 3 on the charts and number 3 in our hearts. What?
Wait, so we have a number and number 3?
Nope. Okay. Then it won't fit on the screen.
We did it last time, remember?
Is there a way I can get you to miss class a little bit?
You'll be gone tomorrow, does that count?
I'll be gone. Yeah, I guess that helps me.
I'll be gone too.
Okay. Okay, what is the domain of? That's as good as I can get, okay? So, again, the same question you have to start with as we did on the other one. What is the smallest value of x that you can plug into this problem and get an answer that makes sense? Negative 6, good, because if I plug in negative 6, negative 6 plus 6 is? 0, and the square root of 0 exists, it's 0. Can I plug in a number bigger than negative 6?
No.
Can I plug in 5?
Yeah.
Yeah, 5 plus 6 is 11, square root of 11 works. Can I plug in a number less than negative 6?
No.
No, because then I start getting negative numbers, and so my answer here is x has to be greater than or equal to negative 6. Okay? Okay, next one. Which of the following equations, inequalities, or graphs determines y as a function of x? Wait, yes. Second one? Okay.
Just yes.
The second one is incorrect.
I didn't look it up.
And the reason why that is incorrect is because it's got an x squared and a y squared. And we have never messed around with anything where there's been a y squared before. What? Number 3, x equals 3.
No. Y equals the x of ours.
The absolute value of x? Yes, that is correct. Okay? Because that has just, Tristan, put your phone away. That has just normal, no, like put it away. You're not using a calculator.
I had it.
No,
I saw a calculator.
no.
I saw a calculator.
Okay, y equals the opposite value of x is y in terms of x because there's an x in there, there's a y in there, and it's just a regular deal, nothing weird is going on, and so that's what we're looking for, okay? Make sense?
Yeah.
All right, next one. Yeah, take your time. Okay, so let's see what we got going here now. Create a table and a graph of each group of equations. Ooh, this looks like fun.
Let's not do this.
Well, yeah, let's do this. Yep, you just write down what I write down. Okay, so 1 over x, 5 over x, negative 5 over x.
That's what you usually do.
1 over x, 5 over x, negative 5 over x. Okay, we went over graphs of these once before. It was a while ago. But we did it, that's why we're reviewing, I guess. Let's take a look at the graph of y equals 1 over x. Always when you are asked to make a graph, what do? You make a table. What numbers am I going to plug in for x?
0.
Negative 2, negative 1, 0, 1, 2. Okay, so if I take that and plug it into 1 over x, 1 over negative 2 is what? Negative 0.5, good, negative 1/2. 1 divided by negative 1 is? Negative 1. 1 divided by 0 is? No. 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 Undefined.
Oh.
Cannot divide by 0. Doesn't exist. Okay? What is 1 divided by 1? 1. And what's 1 divided by 2? 0.5. Okay, so now I can graph this. So negative 2, negative 0.5 would be there. Negative 1 is there. I can't have anything going on at 0. And then I have 1, 1, and 2.5. Okay? So the way these graphs look, I don't know if you remember this from before, but if I pick numbers that get closer and closer and closer to 0, then 1 over that gets bigger and bigger and bigger. Okay? And same thing on the other side. All right? What's that?
You need to draw that.
Mm-hmm.
Okay.
Okay, so there's the graph of y equals 1 over x.
Wait, we have to draw this graph out?
Yeah, I said what I write down, you write it down.
You didn't clearly write it.
That's out.
Yeah.
Okay, so now let's take a look at the graph of the next one, y equals 5 over x. And so it's the same thing as we did with this one. You're going to plug in some different values of x there, -2, -1, 0, 1, 2. If I plug in -2, what's 5 divided by -2? 2.5, but it's going to be -2.5 because the positive divided by a negative is a negative. If I plug in -1, what do you get?
Wait, what number is this?
This is still the same one. -5. 5 divided by 1 is -5. What happens at 0? Undefined. What's 5 divided by 1? What's 5 divided by 1? 5. And 5 divided by 2 is 2.5. Okay? So now I have to graph these points, and I'm going to do it on the same thing. So -2, -2.5 is here. -1, 5 is going to be there. Okay, 0 is undefined again, 1, 5, 2, 2.5. And so the difference between these two graphs is what's different here, would you say, between the red one and the green one? How did having it be 5 divided by x make it different than 1 divided by x? Right, the graph is farther away from the x and y axes, okay? So the bigger that number is, the farther it's going to be away from the axes. So if we had 10 over x, for example, then it would be, somewhere way out there, okay? All right, let's take a look at the -5 over x. And let's do this. No, let's not. What color should I use? Blue? Go blue. Okay, so same thing, except now since it's -5 divided by x, if I go -5 divided by -2, what do you get? 2.5. If I go -5 divided by -1, I get 5. This again is going to be undefined. -5 divided by 1 is -5. And then -5 divided by 2 is -2.5. So can you see by looking at the table what's true about these answers compared to these answers? They're the same but opposite. They've been flipped. And the same thing is going to be true of the graphs. Now if I go -2 to 2.5, it's right there. -1 to 5 is right there. And so this one is going to be like this. And then the positive one is going to be the same but flipped over also. So I go 1, -5, 2, -2.5. And so that one's going to look like that, okay? So the bigger the number on top, the farther it moved away from the x and the y axes. And then when I had a negative number on top, that flipped the graph around because the answers were the same, but like you said, they were opposites. Okay? Can I change the page?
Yeah. Yes, sir. Yeah, I don't see
Okay, so that's what you would write in the what do you notice thing. What do you think a +3 on the end is going to do? It's going to move it up 3. What do you think a -3 on the end is going to do? Would move it down 3. Okay, so we can skip those graphs because you know those. All right, how about these guys right here? Do you remember what the graph of the absolute value of x looks like? No? All right, let's do these the quick way. Cheat a little bit here.
Peter,
30 miles an hour.
is it gonna rain if you punch it on
I believe so, yeah.
Oh no.
Okay, so first one, it said absolute value of x. Okay, and then the next one said the absolute value of 2x. So there's the absolute value of x, and the other one is the absolute value of 2x. What is different about those two graphs? This first one is the absolute value of x. This one is the absolute value of 2x. What's different? It's slimmer, narrower. Okay, good. So let's put that down for, what do you notice? Tristan said y equals the absolute value of 2x is slimmer. Okay? Slimmer. My thing doesn't like making curved lines when I do it this way when I write on a different document. Okay. What? Not in English, no. All right, then let's take a look at y equals x plus 2 and absolute value of x plus 2 and y equals the absolute value of x minus 2. And see what we notice about those. So what was it, x plus 2? Okay, so there's y equals x plus 2, there's y equals x minus 2. How are those two graphs different?
They're on the opposite side.
Shifts left. Okay? So we're going to write that down for the next answer there. Whoops. Well, then you should pay better attention. Okay, y equals...
That's not y.
Yeah, actually that is y. It just is hard to write it like this.
I'm just Yes, you already said. No.
Okay, so shifted, right or left? The x minus 2 went to the right, actually. That was the second one. How far do you think it was shifted? 2. And then the other one, y equals the absolute value of x plus 2 is shifted left 2. So again, I don't know if you remember, this is something that we talked about. When you do things inside the parentheses like that, then that moves it to the left or to the right. Okay? What are you doing with the calculator right now?
Calculating.
Calculating what? Okay, what do you think happens? We won't need to graph this if you do absolute value of x plus 5 or absolute value of x minus 5. What's going to happen?
Plus 5 is gonna.
If inside the absolute value sign it went to the left or to the right, if it's outside, what's going to happen? Up or down. Okay? So absolute value of x plus 5 is going to be up 5. And absolute value of x minus 5 is going to be down 5. Okay?
Sounds good to me.
Sounds good to me too. All right, I'm going to make that go away.
No. Do it.
That was cool. All right, so with that in mind, based on what we just did, which graph are we looking at right there? Y equals 4x squared would look like a what? Y equals 4x squared would look like what?
A parabola.
A parabola. Does that look like a parabola?
No.
No. Y equals the absolute value of 4x we just did. What did those look like? a v. Do we have a v?
No.
No. Y equals the square root of x plus 4?
Yeah.
No. Y equals 4 over x. Those were the ones that we were doing the first time. Yeah, that's what this graph is supposed to be of. And so my answer
So
there
number
is
x squared is parabola.
D. Yeah, x squared is parabola.
You trickster.
Whoa.
Watch your computer.
Whoa, do that
Watch
again.
your-
Yow!
Next. Keep doing it.
Why doesn't it stay?
There's just a lag time when I do this. That's why I can't write curved letters too, because it's too slow. Okay, so this one right here, now we have a some data that's supposed to be based on
Nice.
iPod sales, iPad sales, and it looks something like that. Okay? Which equation best represents the total profit P that an employee makes for selling any number of iPads? So that is a linear function, correct?
Correct.
Okay? So that's going to be in the form of y equals, what's the general form? mx plus b, good. And the slope, m is the slope, and b is the y-intercept. So what's the y-intercept right here? 75, so you know it's going to be something plus 75. So it's either going to be this one, or it's going to be this one, okay? The way that you can tell is by looking at the slope. This goes up 75, because each one of the squares in the vertical direction is 75. It goes over 1, right?
Yep.
So the slope is what?
75 over.
75 over 1, so it's going to have to be that one right there. So B was close, but not quite.
No cigar.
No cigar. Why would you want a cigar anyway? I don't know.
It's an old saying.
It's
No,
an
I
old
did-
saying.
I
It
want a
comes
cigar.
from when you go to the fair. All right. Let's take a look at another one here. All right, so this one says, Pizza Hut employees are aware that a pizza pirate has infiltrated Pizza Hut. They have decided, oh, I can't see because somebody is blind. They have decided to leave one pizza out for the pirate to see what he or she does with it. On the first day, the employees set out a full pizza. When they arrive back at work the next day, day 2, there's half the pizza left. They again leave the pizza out at night, and when they return the next day, day 3, there's a fourth of the pizza remaining. This process continues for a total of 10 nights. On the 11th day, how much pizza is left? Okay, well, it's going to be pretty dang close to none. All right?
Why would you want to slowly
Yeah, I'm not really sure what they're trying to do here. Okay, so first of all, we need to make a table.
30 seconds.
Wait, so which one are we doing? Table?
We're going to do table, we're going to do them all.
You?
Yeah. Okay, so if you start with the table, on day 1, how much pizza did they leave out? One whole pizza.
No.
On day 2, how much was left when they came back? Yeah, half a pizza. On day 3, how much was left? 0.25 or 1/4. Okay, on day 4, we need to do this for a total of 11 days. Get a life, Pizza Hut employees. 1/8.
116.
Okay, and where are you coming up with these numbers, brilliant boy? Multiply the bottom number by 2, so then this is going to be 1/32, 1/64, 1/128,
That is not a lot of pizza.
That's
1/1024th of a pizza. Not very much pizza.
Pretty good buy.
How big is the pizza?
Can you draw like a pie graph and then show how much that would be?
Yeah. Would you like me to?
Yeah.
Wait, wait. No, like a little bit bigger.
No, wait.
Wait, time out.
That's how much.
No, it's not.
Yeah, it is.
That's like about
Really
50th,
I
probably.
did the measurements exactly.
No, do it, calculate it with the calculator.
It'd probably be
No,
a
let's
big
not.
line.
Okay, so that would be the information in a table form. And they would also like for us to write this information in a graph, which is good because I know you guys love to do graphs.
Oh, yeah. They're my favorite, Mr. Aldrich.
I know, right? And so since we're only dealing with positive days and positive amounts of pizza, I only need the first quadrant. And what is my scale down here on the days going to go by? What should I go by here?
10.
Tens?
Why would
You
you
only go
want
up to 11.
Oh, 1.
Let's go by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now for my pizza scale.
You should go down by.
Yeah, it's going to be a little bit rough. I'm going to start with the 1 right there. And then it gets cut in half each time. So I'm going to have to go 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, 1 blah, 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 blah. Okay, so on day 1 there was 1 piece of pizza there, or 1 pizza there. On day 2 there was 1/2. Day 3 1/4, half of that. And you see how these dots are getting closer and closer to the x-axis each time? So that's what the graph would look like. Huh? What?
Talking about
I know,
Yeah,
that's
he
why
was.
I'm trying to ask.
I said I was going to hear the water balloon.
I was kidding.
Yeah. I wasn't.
I wouldn't do that to you.
I know.
I would.
What the heck?
I'd
I'd hate your house.
Hey,
I would just egg us
Wait, I'm
out.
not
Okay, then since it's cutting in half each time, are you ready?
Yeah. No.
The formula,
Are we done yet?
now we are, the formula for that, the function rule for that, is y equals 1/2 to the x. What would it be if it was getting cut in fourth every time? Y equals 1/4 to the x. What would it be if it was doubling every time? Y equals 2 to the x. What would it be if it was quadrupling every time? Y equals 4 to the x. So since this is getting cut in half every time, it's y equals 1/2 to the x. Brianna, my favorite student?
Whoa.
Oh, okay. You still are my favorite student.
What?
Okay, so we did
I was just joking.
table, graph, equation, so we're all done with all of that. All right, so let's keep going here. We're getting close. All right, number 6, write and graph the inverse variation in which y equals 6 and x equals 2 by following these steps below. So we have not talked about inverse variation in this class, is that correct?
Right.
Okay. Inverse variation means inverse variation means when you multiply the x and the y together, you get the same number every time. So those of you in here that actually do need to pass this test in order to graduate and actually care about that fact, you might want to write that down on a separate sheet of paper that you'll study a little bit before you take the test. Inverse variation means x times y equals k, and that number is called the constant of variation.
Why is it just a C?
Because C is reserved for the speed of light, I think. I don't know. Either that or math teachers can't spell very well.
So inverse variation x, y equals k.
X times y equals k. So once you know that, it's a really easy question. What does k equal in this case? 12. Because 6 times 2 is 12. So k is 12, which means my inverse variation equation looks like that. Okay? All right, so if x times y has to equal 12 every time, if x is -6, what would y have to be? -2, because -6 times -2 is 12. If x is -4,
-3.
then y would have to be -3.
-6.
-2 times -6 is 12. 0 times,
Can't work.
can't work. Sad face. 2 times
6.
6, that's the one they gave us to start. 4 times 3, and then 2. Okay? And so, will I slow down? Sure. All we need to do is graph these. Okay? So -6, -2, I go to the left 6 and down 2 and put a point. -4, -3, I go to the left 4 and down 3 and put a point. -2, -6, I go to the left 2, down 6 and put a point. And then on the other side it is 2, 6, 3, 4, and 6, 2. And so do you kind of recognize the shape of the graph? This will be about the 4th time we've messed with it today. Okay, it's going to look like that. Ooh, that was a good one, you got to admit. Totally
Yeah, that was a
missed
good one.
It was actually kind of good.
Last one. Here, Joe.
That was classic.
Okay, so it looks something like that. So when you have y equals a number divided by x, that's how your graph roughly comes out looking. Okay, we got it? I'm going to make it go away in 3,
Good.
2, 1. Okay, then it looks like the next thing is the beginning of a new section, so I'm going to cut it right there, okay?